So today we're going to talk about two different forms. So basically, these two are 3.4. So we're going to talk about slope-intercept form. We're going to talk about how to graph by using a slope and a point on the line, also known as intercept. And then this down here is 3.5. We're actually not going to do this. So this is 3.5. We're going to talk about point slope form. And then we're going to talk about how to write an equation. So today's, and it's actually kind of nice because 3.4 and 3.5 go together pretty well. So I'm kind of glad that it worked out this way because I feel like they work together really well. So yeah, so let's talk about the first one. This is slope-intercept form. So you probably maybe have heard of it before. Y equals mx plus b. Remember from Monday, something we'll use a lot is the slope. I always think of that as the rise over the run. Remember, if we're talking about our coordinate plane, a rise of a positive is going up, a rise of a negative is going down, run of a positive is going to the right, run of a negative is going to the left. So that's what I think about when I think about a slope. We also had that slope formula, which we'll talk about a little bit later, that y2 minus y1 over x2 minus x1. So that's all kind of slope stuff that we already talked about on Monday. The y-intercept, what does that mean? What does that even look like? So basically, we're going to have some kind of graph. Let's say it looks like that. Remember, this is the y-axis, this is the x. So the y-intercept is going to be this point right there. It is the point that your graph is going to cross the y-axis. So that's what's called the y-intercept. So hopefully that makes a little bit of sense, but that's kind of, yeah, so that's the slope-intercept form. So what does that look like? Well, let's first see if we can identify some of these parts of it. So we have the slope and we have the y-intercept. Remember, our form is y equals mx plus b, right? So I think of it of y equals some number in front of x plus some number, okay? And the number in front of x is going to be your slope. So in this case, y equals 1/3 x minus 7. I would think that our slope is going to be 1/3. Extend this line a second. And I think that our y-intercept, remember, you always bring your sign with you. So my y-intercept in this case is going to be a -7, okay? So why I extended these lines here is, remember, I'm always thinking about a slope as rise over run, okay? We'll talk about what this looks like to graph here in a second, but that's kind of what that's the way I always think about it. Okay, so here, you okay, Will? I have a -1, and remember, on this one, I technically have a -1 in front of x, okay? So again, this is a weird one, but I have a slope. I have a -1, and I have my y-intercept as 2, right? So one thing that I will encourage you on this one is if, like, up here was kind of nice because I had a fraction, right? So I had a rise of 1, a run of 3, right? This one, the only thing I have to remember is that I technically, this -1 is over 1. So that means I'm going to rise 1, -1, which means I'm going to go down 1, and then I'm going to run a +1. Okay, so that's just the way I think about it when I'm thinking through this stuff. So that's slope-intercept form. So we have y equals mx plus b. Our slope is always in front of our x. Remember, our slope is always rise over run. And then our b is y-intercept. So what does this look like graphing-wise? This one. Now this one's going to be kind of difficult to walk through it. It says graph 4x plus 2y equals 6 using the slope and using the y-intercept. Well, the first thing we have to do is determine those. So in order to determine those, we've got to get it into this form of y equals mx plus b, okay? So right now I don't have that. I have something called standard form, which is a third form, but I never use it. So we're not going to talk about it. It's kind of weird. Anyways, so remember, I'm solving this for y, right? So I'm going to go back, because I want it to be y equals something, right? So I'm going to go back to like the first day, maybe the second day, I don't know, later than that. But anyways, I'm going to put my line there. I got to get rid of all this stuff over here, okay? So the first thing I'm going to do is I'm going to subtract 4x from this side and subtract 4x from this side, okay? So remember, I've got 2y is equal to 6. Now remember, this is a 6. This has an x. Those can't combine. Those are what we call unlike terms, okay? So we have 6 minus 4x, okay? I just want this to be a y. I don't want it to be a 2y. So then what I have to do is I have to divide this by 2, divide that by 2, divide that by 2. What I end up with is y is equal to 3 minus 2x. Okay? Now, I'm super close, right? I want it to be y equals some number x plus or minus some number. Unfortunately, I have y equals some number minus 2x. So I'm not quite in this slope-intercept form. Now this is where you have to be really careful. Remember, the only time I switch signs is when I take things across this equal sign, right? That's why I draw this gigantic bar here, right? I want to flip-flop these around, but I don't have to take them across the bar, so their signs aren't going to change. So here, I look at this and I see this as a negative 2x, right? Not adding 2x to both sides. I'm not doing that. I'm just keeping it on the same side of the equal sign, but flipping it. I'll show you why here in a second. But then this 3, I think, is a positive 3. So this technically is my slope-intercept form, because it's y equals mx plus b. Okay? So again, why I did that is that you might be able to look at this and see that your y-intercept is 3 and your slope is negative 2. I can't. I need it to be in this y equals mx plus b form. I'm able to see it better. I understand it better, blah, 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 right? Okay, so now it says to graph it. So what is my slope? I think my slope here, you would say, is this m. So that's going to be negative 2. I'm going to put that over a 1, right? Because we want that to be a rise over a run. And then my y-intercept is going to equal 3. So then, when it comes time to graph it, you always start at the y-intercept. So there's my y-intercept, and I have a negative 2 rise and a run of 1. So starting at this point, I'm going down 1, I'm going down 2, I'm running 1. Starting at this point, down 1, down 2, run. Down 1, down 2, run 1. Down 1, down 2, run 1. Connect the dots, semi-straight. That's probably the best I've done all day. And there is my line. Okay, so a little bit back from Monday's class. Remember, my slope here is a negative 2x, right? Which should be a negative slope. Remember, put a 0 there, 0 there. Here I am riding my bike down the hill, right? I'm going to want to put negative energy on there to make sure I don't fly too far down the hill. So I do have a negative slope image here. It's a graph. I do have a y-intercept of 3, which I got from this point, so I'm feeling pretty good about the graph. Okay, so again, this one, solve it for y, which is probably going to be the hardest part. Make it look like y equals mx plus b, right? Because we want some kind of m, some kind of x, right? Figure out what your slope is, figure out what your y-intercept, and kind of go from there. Okay, I'll give you about 2 minutes. Go ahead and try this one and see what you get. Okay, 3x minus 4y is equal to 8. Solving for y, right? I'm going to draw my gigantic line. Subtract 3x from both sides. Remember, don't forget this negative here. Okay, so you have negative 4y is going to equal negative 3x plus, oh, sorry, I did that wrong, sorry. 8 minus 3x, right? Don't like this -4 here at all. Divide everything by -4. That by -4, that by -4, that by -4. So I get y is equal to -2. Now remember, a -3 over a -4 gives me a positive 3 over 4x. I don't like the way this looks because I'm looking for y is equal to mx plus b, right? So, sorry, oh, slam, don't slam. Oh, so I'm going to switch these, right? Y equals 3/4 x minus 2. The hardest thing with this one is just making sure you're keeping your negatives where they need to go. So then, what is my slope? Great question. 3 over 4, right? This one's kind of nice. It's set up as a fraction. So I have a 3 rise over a run of 4. My y-intercept is a -2. So starting at my y-intercept, I'm rising 1, 2, 3, running 1, 2, 3, 4, putting a dot, connecting the dots, and that's what my graph looks like. Okay, so remember, you want to solve for y. That's your slope-intercept form. Use your slope. 3, 4. That one's kind of nice when you get. It's actually nice when you get fractional slopes because it helps with that whole rise over run thing. Always start your y-intercept rising and running, and you're going from there. Okay. Again, we had a positive slope when we got there, right? It was a positive 3/4. So hopefully, you know, here I am on my little bicycle. Need positive energy to get up the hill. So hopefully that made sense, and your graph looks something like that. Okay. All right. One last thing on slope-intercept form, which is 3, 4, and then we'll go into 3, 5. Let's say that we're just given the line. Remember, we're looking for y equals mx plus b, right? So I need a slope, and I need a y-intercept. Looking at this graph, remember, this is my x-axis, this is my y-axis. I would hope that you would know that that is my y-intercept. Okay, so I know my y-intercept is a +2, because it's a positive 2. And then slope. So remember from Monday, always start from the left side. I first run into this point. I then run into this point. I'm trying to figure out what is my rise over my run to get me there. So I think here I have to rise 1, rise 2, and then I have to run 1, run 2. So I think that's a 2 over 2 rise, which if 2 over 2 simplifies to just 1, so that means my slope is equal to 1. So if I'm trying to write the equation, all I'm going to do is y equals my slope, which is 1, x, plus my y-intercept, which I learned was 2, and that's going to be it. If I want to, I can just write this as y equals x plus 2. Same thing. Okay. So it's kind of nice if you're given a graph and you're able to determine the slope and you're able to determine the y-intercept, then you're good to go. Okay. So that is slope-intercept form. Now, let's go point-slope form. So I'll give you like just a second to set this one up, and then I'll explain what's going on with it. I'm like the worst when I'm waiting for something. I'm like the worst to keep checking stuff. Like I can check an app on to see like when my test results come back, and I'm just sitting here like checking it every 5 minutes. I'm like, it says it's gonna send an email. My phone will let me know when I get an email, but I have to check the app. Anyway, okay, let's talk about the point slope form here. Okay, so a couple things about the point slope form. This y will never move. It'll always just stay there. This x will never move. It'll always just stay there, okay? The m you get from the slope, and then remember, so we're given some point, some xy point, like we did on Monday when we were doing the y2 minus y1 over x2 minus x1. Remember, I had you label x1, y1, x2, y2. We're going to do the same thing here, and I'll show you what I mean. So it says, write equation line passing through the point 3, 1 with a slope of 2. First thing I do, this is my x1, this is my y1. So it's the x term of my first set of points, it's the y term of my first set of points. This is my slope. Formula, plug it in. This y is never going to change. Y1 I get from right there. M I get from right here. X1 I get from right there. And that's it. So this technically is the point slope form, and that's it. Now, the question says write it in slope-intercept form. So remember, slope-intercept form, not to keep saying it, is y equals mx plus b. So that means I've got to solve this guy for y. It's nice, it's a two-stepper. First step, distribute. So I get y minus 1 is equal to 2x minus 6, right? 2 times x is 2x, 2 times negative 3 is negative 6. Final step, add 1. Make sure you add the 1 there. So I get y equals 2x minus 5. And that is it. Okay? So that's it. So remember, point slope, you're given a point, you're given the slope. Use this equation, you're going to plug in your y1 there, your m there, the x1 there. The other y and x, they don't change. They're set. Okay? Go ahead. Don't do negative, just do negative 3 for this one. Don't do negative 1/3. So sorry, this is funky, but the slope is going to be negative 3. Okay, go ahead and give that one a shot. I'll give you like a minute and a half to do that one, and then I'll kind of walk through it. And here, oh, there's your point slope form. So figure out what your x1, figure out your y1, plug in your m, and then go from there. And I'll give you a minute and a half. Okay, x1, y1, m, right? So I get y minus 2 is equal to negative 3 x minus 5. Do we all agree, right? Y minus y1, which is a 2, m, x minus x1. Next step, distribute. Remember, you're distributing in a negative 3, right? So I get y minus 2 is equal to negative 3x plus 15, because a negative times negative is a positive. Last step, add 2, add 2. So I get y is equal to negative 3x plus 17. And that is in slope-intercept form. Okay? So graphing in point slope form is actually one of my favorite. Okay? So this one says graph the line through 1, 2 with a slope of negative 1/3. Remember, my slope, and I would encourage you to always stick the negative with the top number. So I'm thinking this is a negative 1 rise over a 3 run. Okay? So now, instead of using the slope-intercept form where we're starting at the intercept and then doing our slope, all we're going to do is the same thing, but we're going to start here at this point. So we're starting at the point 1, 2, rise of 1, run of 1, 2, 3, put a dot, connect the dots, and we're good. And that's it. So remember, slope-intercept form, we were given a slope and an intercept. So we started at the intercept, did our slope. Now, point slope, we're given a point and a slope. So now we're just going to start at the point and do our slope. Okay, so hopefully that makes sense, but it's pretty slick. And then this one I'll just show you. So again, they started at the point 2, negative 3. They actually have the same slope. So they're going down 1, right 3, put a dot, connect the dots. Okay, so that's the nice thing about using point slope form is that if you're given a point, you start at the point and then you do your slope. Okay. Last questions, and I'll give you 1 minute to do this one, is I want you to write both of these in slope-intercept form. So try A and B. And then I'll tell you a little trick that I learned, or that finally clicked like about 3 years ago, but I don't know why it took that long to click. But promised my son I'd have candy corn, so I have to go find some candy corn somewhere. This is that time of year. Okay, so write an equation in slope-intercept form. Okay, so this one, I'm given a slope and I'm given an intercept. So remember, it's just y equals mx plus b, right? In this case, y equals negative 1x plus 5. Because this is my slope, this is my y-intercept. I mean, if you wanted to, you can just write that as y equals negative x plus 5. Okay, pretty straightforward. This one takes a little bit more time. Use that formula. This is x1, y1, there's my m. So y minus 4 equals negative 2. X, remember, minus a negative 1, be careful, it gives me a plus 1. Distribute. So I have y minus 4 is equal to negative 2x minus 2. Add 4 to both sides, y equals negative 2x plus 2. And I am done. Okay, so one thing that clicked in my mind about 3 years ago and I never really understood it is for some reason, whenever I did these, I would always lean towards the point slope form because even if I was given an intercept, I would put that into point slope form. I had that formula memorized. I felt comfortable with it. I felt comfortable distributing and solving, blah, blah, blah. About 3 years ago, it hit me that if I'm given a slope and if I'm given an intercept, I need to use the slope-intercept form. If I'm given a point and I'm given the slope, I need to use the point slope form. So that sounds weird. For some reason, I would use those terms all the time. We're like, oh yeah, slope-intercept form and point slope form. But I never really understood that if I'm given a slope and an intercept, I'm going to use the slope-intercept form. If I'm given a point and a slope, I'm going to use the point slope form.